And you then, because of the patterns which appeared to be emerging, you then felt, well, we can't just focus this on the UK, it needs to be a worldwide study in order to...
After I'd done that for 6 years, I did a 6-year study of the British sightings and came to the similar conclusions. And I thought, well, now it's got to be expanded. I've got to look, if these things are coming from space, if I'm going to identify any activity coming from space, I'm going to have a global sample.
Right. And how on earth did you go about that then?
Well, it was one of those sort of examples of serendipity, really,
Right.
because I was associated at that time with a group in Manchester called Direct Investigation Group for Aerial Phenomena. One of the members, I mentioned this need at the meeting, and one of the members, who was a librarian called Peter Rogerson, a librarian in Liverpool, said, well, I'm just in the process of creating a list of type 1, as they called it then, type 1 events.
So you got this database from this chap, and then what happened?
Well,
then?
he came out gradually in a magazine every week, and he used to send it to me.
Right.
Let me have a copy. And I analysed and selected out the ones that I thought were meeting my requirements. A strange aircraft, you know. And they went back into the 1800s.
Right. Oh.
Michel was the other one. Yes.
Okay, so he suggested that they may be following a geodesic path. Can you explain what that is?
Well, he noticed that after an outbreak in France in the 50s, I think it was, that he could put a line through several sets of points, or lines, I should say, and he thought they were following straight lines. So it was a straight line mystery, basically. You see. Now, what he went on to do was to say, well, straight lines are part of great circles over the globe. So he put forward the view there was probably a great circle linking the events all over the globe. And he managed to produce a book putting this theory out, not more than one book. And a lot of people believed it. Now, the fact of the matter is, when I looked into it, it didn't hold up very much, to my analysis.
So this did not consider at all that something could actually be in orbit around the Earth. This purely considered that something was moving along a path along the ground, essentially, and it wasn't considering the relative position of something which might be in orbit.
No, it wasn't indicative of something coming from space. It was indicative of someone perhaps choosing to put things on a great circle path around the world.
So you then, from that idea, I guess, came up with the idea that no, they're not following a specific track on the Earth, they're following a track in space.
I was looking for indications from all the evidence I got, the global evidence. Incidentally, out of all the thousands of things I looked at, I selected, I think, 450 cases, good cases, historical cases, going back to the 1800s, the first one, and then into modern times, or more modern times. And the end of my database at that time was about 1971, and I called that a day with 450 cases. I then began to analyse those and to see if I could find a linking pattern which might explain how they had occurred.
The thing that you thought of was that perhaps that these craft were coming from another craft which was in orbit around the Earth, or in some kind of temporary orbit around the Earth. Is that?
Well, that was my first thought was that perhaps if someone was coming here from another system out there, they'd probably be coming into the Earth, toward the Earth, from the same direction in space, whatever at the time of year. And I drew a diagram that showed the Earth moving around in its orbit. And what it would mean would be if the idea was if these things should come from one direction in space and then go into a parking orbit of some kind, so that they could scan the area below, then that would occur, that parking orbit would occur at all sorts of times of day, depending on which time of year it happened to be.
Yes. So they come from outer space and from, let's say, I don't know, the Pleiades, and they approach the Earth.
Well, we don't know where. I don't know where.
I'm just using that as a fictitious. So they come from that angle, whatever the angle of the Pleiades is relative to the Earth, and then they fly into a parking orbit. But the Earth is rotating beneath that parking orbit. Therefore, that orbit is drawing out a path on the Earth. And what you're saying is that in order to actually get any kind of correlation with what's happening on the ground, you need to know exactly what time these events are taking place.
If this was the correct scenario, then there would be this spiraling kind of link up.
Right, and prior to that time, nobody had really correlated the strange aerial craft. They correlated the positions on the Earth, but not with the actual timing of the event. When you managed to get some of this global data, you decided to plot it out on a graph, and you represented positions on the globe with the angles of longitude and latitude. Can you just explain that particular graph to us, Roy?
Yes, these are two typical graphs that I produced at that time.
Okay.
And what we have here is latitude and longitude on the Earth, depicted in Cartesian form.
Okay, so the line going upwards is basically how far north or south the event took place,
correct, yes.
and the line going from left to right is how far east or west it took place.
Yes,
so every point on that graph represents a point somewhere on the Earth.
Yes,
okay.
One of the selected
data. Okay, so it's kind of the Earth unfolded in a certain into a flat. And you try to find patterns to see whether
linking those points, which represented an orbital path of some kind.
Right.
And I did a lot of exercises of this kind.
So a curve in that instance would represent a satellite going around the planet. It was
just going through those over those.
So those curves that you've got on that left one there, that is what, if you just move it to your, if you can if you put that one in front of the camera, so those curves, that is the path above the Earth that an orbiting satellite would take
to intersect those points.
So
or overfly those points.
Yes. Okay, and you didn't. I gather that you didn't. It didn't seem to be telling you a great deal from these graphs. Am I right in thinking that?
That's right. Using normal type orbit periods, which affects the pitch of the spiral on the globe, they just didn't line up properly. There's nothing there that would make me think, yes, there is something here.
Okay.
And it wasn't. Until I changed, I had some more data, more processing, more data, that I decided eventually to try something quite ridiculous. It seemed to be, and that was that those periods, orbital periods, are the time taken for a satellite to go around, once around the world. They're generally 90 minutes plus for not ordinary Earth satellites. Right. But there were some indications from other processing I'd done that in fact 65.45 minutes was something important in linking these things. So I tried, in sheer desperation eventually, I tried 65.45 minutes, which incidentally divides the day up into 22 equal parts. Okay. Then, when I put my tracing paper with that period over the graph, and by the way, I did both these with paths in retrograde, in a retrograde sense over the Earth, we're going against the Earth's rotation.
So this is where so this is where the satellite, or the thing that's going around the Earth in orbit, goes the other way to what the Earth is against the Earth's
that's
rotation.
The retrograde sense, yes.
Retrograde orbit.
Yes.
Okay.
Now, or it can be progressive in the direction of the Earth's rotation.
Okay.
And the shape over the Earth, the spiral, is a different shape, you see, according to whether it's going with or against.
Yeah.
Now, from the shape of these curves, and using this ridiculous 65 points,
which is an extremely fast orbit time. There are no, am I right in thinking there are no satellites going around the Earth now that go around that quick?
There could be no satellites operating at that sort of speed.
Okay.
And it was a ridiculous kind of, it seemed on the face of it to be a ridiculous thing to try.
Okay.
But when I laid those lines over the points, there they were lining up over the points that I'd under that kind of track, you see.
Okay.
So it seemed to me, well, I can't explain it, but we're not dealing with our technology anyway. We're dealing with somebody else's and much more advanced technology. And I reasoned that if someone happened to be orbiting up there at that speed, that they would have to hold themselves in orbit. If they're coming from outer space and slowing down to 25,000 miles an hour, which is the sort of order of it at about 400 miles, then they would have to hold themselves there to progress all around the world. And that is beyond our understanding. You know, at the moment we haven't got technology like that. But it did seem as if that pattern fitted. And not only did it fit, there's something else to bear in mind, that it was fitting a historical data spread on the Earth.
From the 1950s and 60s.
Right back to the 1800s. Right. And there was this link-up that created this very good indicator that this sort of thing was going on, and it was going on for a long time.
So from your analysis of many of these events, you've determined that probably the most likely orbit is this 65-minute orbit.
And it was then I discovered that there appeared to be several paths in space, not just one, but several at different angles to the equator. If you think of them as hoops around the Earth, these stationary orbits, it wasn't just an indication of one fixed orbit, but several.
And if something was coming from outer space and did want to, let's say, land on Earth and do some analysis and then go back, probably a plausible thing for it to do would be to come in, stay in orbit, and then pick the thing up again, drop the thing off, and then pick it up again, and then off it goes. So there's actually something being deposited.
Yeah. My impression was eventually that these things were not, if they were coming in along those paths, they were probably not going into continuous orbits. They were coming in onto one of the chosen paths. And by the way, what developed from this was a whole series of fixed paths over the Earth's surface, which seemed to be like the equivalent of air lanes, things they could follow if they wanted to.
Yeah.
And so the picture that came to me was that they might be latching on to the one that took them over a place they were interested in, scooting over it, putting a probe down into the atmosphere, and then scooting off into space again, not going round and round and round, because the natural thing for a thing to do, travelling at that sort of speed, would be to shoot off into space again, not to orbit.
Right.
So that's the picture I want to get over. The people have often thought that I'm saying they're continuously orbiting. No, I don't think for a moment they're continuously orbiting, even though there is a continuously orbiting sequence of paths around the world.
That they can lock into and then lock out of.
Yeah, that's right.
And you believe that there are two different types of orbit. One where the craft, or as you call it, the hypothetical mothership, we can use that word, is coming from the direction of the sun towards the Earth, or from the outer reaches of the solar system.
Well, that was the next step, basically, to discover, if I looked at the timings of all these things underneath, what whether there was this link with the stars I had been looking for initially.
Okay.
So I looked for location, looking to see how the times of the events actually were located in the heavens above.
Okay.
What star was overhead at that point, and so on and so on.
Mm-hmm.
And by, in effect, looking to see if there were any great circle links
Right.
between those timings,
Okay.
that would perhaps indicate a position where the things were coming, you know, the direction the things had approached them. I should say that this exercise led me to believe that there were two favoured orbital, when I say orbit, two favoured paths, injection paths and what's the word, return paths into space,
Right.
which were fixed in space, and that was the first sort of discovery. Really.
Right. And so where were they coming from then? What was?
I don't know. They were coming from two orientations,
Okay.
and the fact is that orientation was very much a circle in space, if you like, where they might have anywhere in that area, on that circle, on the circumference of that circle, they might have been coming from.
Right. Okay.
So it didn't define a particular place in space they were coming from.
Okay.
It was defining the angle that they would be approaching the Earth at.
Right.
There were two orientations in space that were favoured,
Mm-hmm.
and two others that were favoured in the way that they were linked to the sun,
Right.
to the position of the sun among the stars during
Okay.
the course of a year. And they were linked to the sunset and sunrise terminators on the Earth,
Right.
specific points on the Earth, on the terminator.
So this is a point on the Earth which is basically between night and day. So it's
That's
where
right.
it's like
That's
a black
where
line going around the Earth.
That's where the terminator is. Yeah.
Right. Okay.
Yes.
And their arrival paths seem to be at those points. Is that?
Yes, one of the paths would be orientated by crossing over the meridian, the celestial meridian that crossed that point on the Earth's surface.
And would that suggest that they're coming from the sun, or?
Yeah, I think so. I think it would be fair to say that, in fact, I deduced from that they were probably coming, in that circumstance, coming from the solar system.
Right.
From
Okay.
either from the sun or toward the sun.
Right. Okay.
But not directly towards the sun,
Right.
except at the equinoxes,
Right.
because of the tilt of the Earth affecting the terminator, the slope of the terminator on the equator, on
Okay.
the globe.